All right, so welcome everybody to the Zephyr on Nordic's nRF52. My name's Joe. I'm from Dojo 5, and I'll be today's presenter discussing the Zephyr on Nordic nRF52. Zephyr's pretty exciting because it's just so new, and Nordic's really moving towards Zephyr as a platform for all of its tools. And all of its chips. So you kind of, if you're familiar with Nordic already, they have a nice line of BLE and more recently cellular products that are being used in all kinds of connected devices. They have a pretty large market share, and you see the nRF52 devices in a large number of places. So it's been a really interesting product, good for customers that we've helped to build their next level of connected devices. And then Zephyr is a new technology that I think a lot of embedded engineers are interested in, and it's going to be kind of required to get things rolling. Real quick, my name's Joe Schneider. I am, like to talk about myself as a family man, dad of 3 girls, and I have an amazing wife, so lucky there. And also been doing embedded software for 20 years. So had a chance to see a lot of different technologies flow through, and excited about all of the connected devices that we're seeing in the last really 5 to 10 years. Done a lot with agile software and agile transformations, things like iterations and sprints. Did a lot of that at a previous life at John Deere too, where I worked for about 10 years on their autonomous vehicles platform. And more recently in a couple of other kind of services related companies before starting up Dojo 5. And I've just see myself as having a passion for improving the state of the art. I feel like the web and mobile guys have gotten a lot of cool tools in the last 10 years and just done a ton of innovation. And I think there's a huge gap in the innovation that's been made in the embedded space. And so really excited to, that's what Dojo 5 is all about, is really bringing modern tools, modern processes to the firmware lifecycle. Dojo is an environment for immersive learning, and that's what we try to do both internally as well as externally with our clients as well as, and then 5 is really a foundation and family, making sure our clients and our employees are all are feeling a part of a family, respect for each other and for our broader community and engagement with our community. But let's talk about nRF5 and 52. If you have some experience with the nRF52, they've got some great dev kits, really easy to get going on. And they've had this nRF5 SDK that has kind of been the mainstay for the last, I'd say, 5-6 years. It's how you've been able to program this thing. It has no RTOS. It uses something called a soft device for BLE support, which has been great. It is very great BLE support out of the box. You can get up and running really quick. Great examples and driver support, which doesn't always happen from other silicon vendors. And so I really appreciate Nordic and the speed with which we've been able to get products up because of the quality of the examples and their SDK. And just as I mentioned, a solid BLE foundation. But as things have progressed, Nordic has just released in the last 6 months a couple of their first multi-core devices. And the soft device model there wasn't a clear path to scale that to multi-core devices. And I think they also saw an opportunity to start to engage an open source tool that was starting to hit the scene called Zephyr. And so Zephyr really began as a product through Ionic Virtuoso, and then Wind River bought it. And for those who have been in the embedded market, Wind River's a pretty popular or famous name. They've been around for at least 20 years, if not longer than that, doing famously Mars rovers and other things with their VxWorks product. They've also had Wind River Linux, which is a Linux distro really focused on embedded. And then more recently, probably about 10 years ago, they acquired Virtuoso and they rebranded it as Rocket. I think they struggled a little bit getting Rocket to market, and so decided that, or really productizing it, commercializing it. And so they decided, hey, let's rebrand this as Zephyr and just really let it be free. And so they gave it to the Linux Foundation. They're still attached to it to some degree. But it is really open source software and a pretty exciting product. So Zephyr, it's really built with Linux principles, but they found that to run embedded Linux you really need like at least a meg of RAM. You need a couple megs of flash and have a file system and a kernel image, and there was kind of this gap as far as like smaller embedded devices that weren't really Linux class devices, but needed some kind of RTOS. And so that's where Zephyr really fills the niche. It's been fairly popular over the last couple of years and has over 40,000 commits. So there's quite a lot of innovation happening on Zephyr. As you can see, they're getting to the point where they're getting really frequent releases as well. They had their 2.0 in September, 2.1 in December, 2.2 in March, and then now just 2.3 just a few days ago. And they're getting a lot of pretty valuable driver support. Nordic has also, the whole reason for this discussion is that Nordic has taken a pretty heavy interest and made a pretty significant investment in making sure that nRF52 tools are supported pretty well by the Zephyr ecosystem. So they see it as a strategic move moving forward. So the goal of this talk is really to just kind of show you how to get up to speed really quickly on Zephyr. I'll show you the dev kit that I'm using, which is easily available for fairly cheap, 40, 50 bucks on DigiKey, and gives you a lot of capabilities out of the box. For Zephyr, it has a tool called West that we'll be using. It's what we call a multi-repo tool. So it helps you handle multiple repos, and Zephyr is divided up into multiple Git repositories that help kind of organize the data. In this case, West we'll mainly use West init, West update, and West build, and those will help us kind of initialize our code repository, update all of our repos so that they're up to the latest, greatest code, and then do a build and be able to run some stuff. I just also mentioned that Segger Studio, Segger is a company that does a lot of embedded tooling, debuggers, and emulators. They have a nice IDE and debugger called Segger Studio. It's free, and Nordic loved that project as well. They end up buying out a worldwide license. So if you're working on any Nordic-based product, it could be one of their dev kits, or it could be a proprietary, like a custom PCB board. You can use Segger Studio for free under Nordic's license. So it provides a really nice debugging experience. Support for Zephyr is available, but you do have to use the Nordic edition, and I'll walk through what exactly that looks like and how you get that. It's a specific edition that you can't download from Nordic's site or from Segger's site. You have to use Nordic's kind of path to do that. So the first step in getting started with Zephyr is to install a number of dependencies. As I list here, CMake, Ninja, Python 3, Ccache, gperf. There's a lot of them. And Nordic provides this really nice nRF Connect SDK tool. And I'm just gonna share what that looks like so that we can, so you can kind of see what that looks like. Let's see, nRF Connect. So I'm gonna pull up a tool called nRF Connect. This is downloadable from Nordic's site. And it looks, here, I'll stop presenting. So it looks like this. Where did it go? Here it is. And I'm not going to grab the update right now, but it looks like this. It has a lot of different kind of, it's almost like a launcher. It launches a lot of different kind of sub applications. There are things in here for programming your Nordic kits. If you have one of their cellular devices, you can access that through here. There's also a number of tools for sniffing and debugging things. In this case, what we're looking for is this getting started assistant, guide to set up the NRF Connect SDK. So when you open that, it launches this, and it walks you through a number of setup steps. And this is really specifically for Zephyr. So nRF Connect SDK is pretty synonymous with Zephyr. It will, depending on what type of computer you have, it'll walk you through installing the tool chain. It'll either tell you the instructions, you can run them manually, or you can have the tool run them for you, and then you can verify that they're done at each step. So it's really nice. It does, it installs all of these dependencies, and then it also walks you through installing GCC, and it's really the ARM version of GCC that's been that's released by ARM on a regular basis. And it is really important if you decide to install this manually, or you end up doing it yourself, or maybe you already have a version of ARM GCC installed, just make sure you've got the right version. There are incompatibilities between different versions of that embedded toolchain, and I found that if you don't have the right version installed, you can run into some issues. Some of them are obvious at compile time, others are only obvious when you run, so it can be kind of some nefarious bugs that you grab. And then where I tend to deviate from this is they do walk you through cloning the nRF Connect SDK and running some of this. I tend to deviate from this and do this a little differently and a little more manually, which I'm going to walk you through. And then this is the place that you download Segger Embedded Studio if you like to do that, specifically the Nordic edition. This link is not available on Segger's site, so if you go there, you're not going to get the Nordic edition. You'll get kind of the standard Segger edition, and it won't be able to handle Zephyr projects. So you do have to grab the Nordic edition to do that. And then they kind of walk you through, if you want, setting up a project here. So I've done all of that, and we're all set to go. But for those who want to do that on their own, that's how you do it. As I mentioned, GCC in the new tool chain. This is important to have this version. So then what I tend to do is this right here. I'll send out these slides afterwards too, so that folks can have access to this if they want to just copy and paste this. But this is basically what we're doing. I typically set up a Python virtual environment, and that just allows me to isolate all the dependencies that that Nordic's tools and Zephyr bring to the table, and so that I don't pollute kind of my whole computer with that. This is in Python 3, and these commands will work on Windows or Linux or Mac, depending on what you do. It's a little different for virtual environment if you're on Windows, but not significantly different. And if you have any questions on setting up virtual environments in Windows, feel free to email after the talk. Then we're going to just activate that virtual environment. There's a couple of export commands that will set up some environment variables for the Zephyr toolchain. One is just telling it that we're using the ARM embedded toolchain, because Zephyr does target other compilers as well. And then we give it the path to the toolchain, and this path you'll need to update to point to wherever you've installed your GCC path. Then we're going to install a tool using the Python pip installation tool called West. And then, as we mentioned, West is kind of our place to start. We're going to be installing Nordic's kind of patch of Zephyr. So Nordic's stuff is mainlined, or a lot of Nordic stuff is mainlined into Zephyr. So you can go grab the Zephyr proper repo and run a lot of Nordic stuff. But Nordic does have its own fork where it brings a lot of additional kind of maybe more experimental or new chips that haven't been sent upstream. And so that you can find a number of additional tools on top of Zephyr here in the Nordic Playground repo. And the latest version of that so far is 1.2.0. So they kind of release that at their own cadence and pull up the version of Zephyr that they support at the time. And so we'll be using 1.2.0 for now. And then we'll be installing basically once you update the West or update all the sub repos, you'll get a number of other repos which themselves have their own requirements. And this pip install command here is just installing all the requirements that Zephyr might require, or that the bootloader, which we'll be doing towards the end of the demo, may require. So let's go through that real quick. I tend to use Visual Studio Code, so I've got that pulled up here. I'm gonna pull out some of this stuff here, and so here I've got a Zephyr nRF52 folder where I've got some of our stuff set up. Now, if I go into the code directory, I've got NCS already. I'm gonna remove that so that we're starting from a clean slate. And then we'll walk through these commands here. I'm just gonna go dual screen here. And yeah, it's not terribly readable, but I think you'll be able to see on the right side here what we're up to. So Python 3 dash, let's see, I might have a virtual environment already here. Yep, I do. So I'm gonna delete that as well so we can walk through the whole process. So Python 3 vm.vm, that will create a virtual environment for me in this area so that I'm able to isolate my Python work. I'm gonna go into that virtual environment and activate it. And now we can see from my prompt that we're in the virtual environment. Now now it's time to set up those environment variables. Let's go back to I've got those in my notes here for my particular setup here. Now we set those up, no problem. And now we can pip install West. Take just a little bit of time. And this will kind of set up the initial, the ability to run West. Now we have access to the West tool, which there it is. And now we can West init, and we'll point to Nordic's repo. And we're gonna tell it to grab 1.2.0 of the Nordic Connect suite, and we're gonna check it out into NCS. And actually checking it out into a folder called NCS is important. There are some issues with if you do not check out to NCS having to do with paths. So now we've checked out just the West directory, or just basically we just checked out their Git repo, but we haven't updated all of the sub repos. If we go inside of here, we're gonna see there's just an NRF folder. And actually there should be a lot more going on. So if we do West update here, and actually behind the scenes, we'll also see that there is a, inside of the NCS directory, there is a .west directory, and that's kind of setting up a lot of the stuff, kind of information about the West repo. So now if we do a West update inside of the NRF or the NCS directory, we will start to download all of the sub repos. This does take a couple minutes. So while we're doing that, I'm gonna jump back to the slides, and we'll just talk a little bit more about what's going on inside, what's happening right now. So as we mentioned, we checked it out to NCS. Initially, we saw just the NRF folder, and it does have some Nordic drivers, basically Nordic specific stuff, but not a lot else. Now that West update is pulling in a number of other things, pulling in the bootloader code. There will be a build directory once we actually build something. It doesn't get pulled down by the West update, but that's where by default all the builds end up. Embed TLS is our TLS library and crypto library modules. Lots of third-party libraries there. There are some additional things that get pulled into Nordic drivers. nRF52 is something that nRF5 SDK folks are probably familiar with. It's basically their wrappers around existing drivers. And then there's a number of tests. Zephyr has a pretty extensive test suite. Dev and testing tools, things like internet connectivity and mock servers and stuff. And then Zephyr Core, and this is really what you'd find if you went to grab the kind of the proper Zephyr proper kernel and stuff. Is all of that's inside here. And what we're also going to find is inside of that Zephyr directory is all of our samples. Here's some examples of where you can find some different things. And so under the Zephyr directory, there's a boards directory, and that's where all the board support happens. You'll find a CPU family, and then you'll find additional like specific boards underneath there. You can see that like in the Zephyr proper directory, 52840, and specifically the PCA 10056, which is the dev kit we're using today, are supported and have been upstreamed all the way to Zephyr. So these have all been, these are all part of Zephyr proper. You'll find over here, like here's some additional boards that aren't upstreamed to Zephyr and are then contained inside of NRF boards, ARM. And so that's how, you know, Nordic kind of allows itself some flexibility and independence from the Zephyr proper projects that it can provide a kind of bleeding edge or next level tech. But that's an important place to look to see if your board is already supported. If you're not, if your board isn't already supported, you do have to do a board port, which isn't too bad. That could be a great topic for another session. We won't get into that today. But fairly straightforward as long as you have a board that is similar to what you are looking at for a custom board. You'll also find under Zephyr, there's samples and a lot of great samples. And this is where I think Nordic's influence on Zephyr, if coming from their SDK, has been really good. There are samples for pretty much every peripheral, for pretty much you know, a large number of kind of use cases and scenarios. So it's a great place to start and to get just to see example code for how you do, you know, one or another things in the project. So and where we're going to be looking for today, just to get things up and running, is samples basic. And so that's where they have, you know, of course, the hello world of firmware, the Blinky example, as well as the buttons, just fading LED. There's also minimal, which is a nice place to start if you just want a blank template. It's just a blank main. And then a couple other things that are under basic. So that's what we're going to be looking at. So let's go back and check on our Visual Studio Code build. So we are now done with our West update. And this is what it looks like. We've grabbed all of the different kind of pieces that were part of all the sub repos that were part of this. You can see we're grabbing some things under modules. We're grabbing some things under can open, and we've got all of that now. So the next step is to run a build, and to run your first build when you don't have a build directory, you need to specify a board, and that you do a -B, and then you specify a board, and that name comes directly from the board that you've chosen, or from the board directory names that I mentioned earlier. And then you point it towards an example project or whatever project you have, if you have a specific user project that you've created. As I mentioned, we're using the 52840 development kit, which is PCA 10056. And so then that gives us a build target of 52840 10056. So let's go ahead and do a build. So West build B nRF5240 PCA 10056, and then we're going to point it to samples basic Blinky. And this is going to start a build. When you create a build for the first time, and I skipped a step. So this is good because people can see what it looks like when you skip a step. Real quick, when you do a build, the build direct when the build directory gets created, it actually saves your build, your board name and your project that you chose. So you, like subsequent builds, you can just do West build, and it will remember that you don't have to put the -B every time. You don't have to choose where you're headed there. If you ever want to retarget it for a different board or run a different example, it's easiest just to completely blow away the build directory. And that is, you know, maybe counterintuitive to some folks who have worked in a different environment before, but that's the intention, is that you have this build directory that just has like a build output, and you can blow it away at any time. And you shouldn't have, you don't want to check anything in the Git that's in there or anything. It's just meant for your build output. So the step I skipped here was this step right here, this pip install. So we didn't install the requirements from both. And I think this is a common step to miss. So I think it's good for folks to see, like, hey, it's not totally intuitive what happened, but what it's really saying here is that, hey, I couldn't find a Python tool called elf tools that helps me do my build. And so if we do pip install our Zephyr scripts requirements.txt, that will install a couple of helpers, one of which is elf tools and a few other things as well. You would get a similar error about crypto if you missed it for the bootloader. And so that's, again, your hint that, hey, I've got some requirements that need to be installed that weren't installed. And this is all, you can see all these requirements getting installed. This is where having the virtual environment for Python is really useful, so that these aren't getting installed globally on my machine. They're only getting installed for my Python related activities, or my Zephyr related activities, so that I'm not polluting that with other things. All right, so we're also going to do this same installation for the bootloader stuff. And this is just off of those slides where this comes from. Just a few, just that cryptography one. So now let's try our build again. Now, because we've already specified the board and the project, we're able to just run West build. It remembers the board that we targeted, and hey, we have an elf file. By default, all of this stuff ends up under build Zephyr, and then you'll find in here, it just always gets called Zephyr, Zephyr.hex, Zephyr.elf. There's a bin file, there's a map file or a listing file if you want to see you know, your symbols and where all of your firmware ended up in memory. And then there's a number of like just build output pieces that are here as well. Kind of typical things. And now the easiest way to move forward then is to do a make flash. So make flash, or I'm sorry, not make flash, West flash. And West flash, and we're in the wrong directory for that to happen, because I moved around. West flash from NCS directory. So now it's basically the board support package that we have that supports the nRF52 840 not only supports not only supports how to build for the 840 dev kit, but it also supports flashing. And so let me stop sharing real quick and just share my screen, and you can see here's my dev kit, and we've got a blinky light. So that's flashing, you know, at a slow rate. And kind of demonstrates that we've been able to run Zephyr on this device. Let's look at what this means then from what we could do to our sample if we just want to play around a little bit. Let's try. So here's all our samples, and here's our Blinky sample, and here's main. Let's just look a little bit at the code real quick. So in our sample here, you can see there's sleep time 1,000 milliseconds or 1 second. There's a lot of stuff happening here for device tree, which is something we'll get to in the end if we have time. But it's kind of one of the major new pieces of Zephyr, I think, to new programmers, and kind of unique to Zephyr and how it works. And then we've got just your typical main, like you typically would. we've got a bunch of stuff up here that has to do with basically determining what pin our blinky light is going to. And then we are setting the pin, just like you would in any other API. And then we basically come down to a while loop. And here I'm actually printing out some stuff. I made a small little modification here, and then blinking it and sleeping in between. So it's the the build process is very similar to what you might be used to in other languages and other setups. We can also pull up the serial port, and I'll just pull that up real quick so we can see it printing. Let's see it printing. Let's see, let me make sure, you know what, I might have. You know what, I wasn't sharing my screen while I was describing that. I'll fix that just a second. All right, here we go. So now I've got Zephyr samples, basic, and then Blinky is sitting right here. So here's our main, and yeah, as I mentioned, we've got a sleep time, we've got a main, and we got a while loop that's basically just writing the pin over and over again. Change our sleep time just to kind of prove to ourselves that we're operating in the right way, or that we can prove to ourselves that we can flash this device and make changes to it. Okay. So I just need to activate my Python environment again because I changed Windows here. And now we can West Flash again. You don't have to build it again. You can just do a flash. It'll figure out that we need to rebuild. It'll flash the device. And now we're flashing at a much faster rate. So that so we're kind of at the point where we feel like we can flash the device and do some blinky. Now there's some pretty powerful configuration that can happen that's also kind of unique to the Zephyr world. And that's using a tool called Menuconfig. So if we do -t Menuconfig, this pops up something that's very familiar to kernel and Linux developers, but not as familiar to embedded developers. And this is a configuration menu. You can find a lot of different drivers in here. This is how you do a lot of like turning on and turning off different drivers. It's like, for instance, if we look at device drivers, we can see that I2C or SPI hardware support is in here. And kind of the preferred mode for turning this stuff on is for you to go in here and select things. By hitting spacebar, you can see I get a little star or asterisk next to I2C drivers. That's how I turn them on. And then once I turn them on, now I've got an additional menu that I can dive into and utilize those drivers, turn them on. For our purposes, let's look at the CDC ACM USB serial. So you can see that there's a USB CDC ACM USB serial driver device. This is part of the, let's see. Yeah, so we have to choose the Well, there's a bunch of settings here, and it's telling me that they're not ready to, not able to use them. It's really telling me that USB device log level off. Well, those are all the logging. So people who have used nRF SDK Connect before would recognize those as log levels for the USB device driver itself. There is additional, as you can see, that, hey, like it's basically saying this particular USB device log level item depends on a couple of other things. And so there's this whole dependency piece that kind of gets built into all of these different settings for the device and all of the device drivers that you'd want to turn on. So like if I want to turn on USB, now I've got USB turned on. Now I've got Nordic semiconductor USB controller, device controller driver turned on. And there are some settings here that you could change. We don't necessarily need to change those. And we don't necessarily want to turn on the USB driver log level. We don't want to debug the USB driver itself. We'd like to see USB output. And so now that we have the USB driver on, now we can turn on CDC ACM class driver, which is basically makes the USB port look like a serial port. And so that we'd be able to print out to it like as a standard out. You can see that there's a number of other things we could add here, like USB mass storage, USB Bluetooth, loop pack, all kinds of other stuff. But this will serve our purposes for now. So then once you make changes, such as the one we just mentioned, you save your configuration by hitting S, and then it saves your configuration. And then you can leave and do a West Flash. Takes a little while, a little longer to build this time around. Well, I kind of went on a limb and tried out this CDC ACM example. I think I'm still missing some piece. Yeah, here we go. So it's kind of telling us, and this is a good exercise that we can go through here. Not something I planned, but we can probably helps to walk through digging through this. So config UART interrupt driven must be set for the CDC ACM driver. So whenever you see something in Zephyr that starts with config underscore, it's really talking about these Menuconfig configuration pieces. It's really, if you've used the SDK, the Nordic SDK, it's the equivalent of the SDK config.h that gets created and where you turn things on and off. That's really what Menuconfig is doing. So we can go inside of Menuconfig, hit /, which brings us to this jump to symbol, and then we can look for our config interrupt, what was it? USB interrupt, and actually you leave off the config. USB, I've forgotten. It is UART interrupt driven. All right. So pull up the menu config, UART interrupt driven. So there we see it's set to no. You can search for it, which is really easy. We can, and now we can see it's red. I can't enable it. I can hit question mark. I can figure out why is that I can't enable that. Well, my guess, you can see the dependencies here, but my guess is that serial support interrupt or serial is not set correctly. But you can see that there are a number of places that these like different shields, different boards that all of these dependencies come from. There's a lot, typically going on here. Serial support interrupt. So let's look for serial support interrupt. That's set to yes. Enable UART serial support. And then UART serial. Yep, so now we've got UART interrupt driven is set to yes. So now we should be past that point. Oops, don't want to do Menuconfig again. So yeah, basically wherever you see those config pieces, you're going to be finding, like if we search the code for config UART interrupt, we'd find that there is code that's in the comp files that basically is defining those, but you'll also find that like in UART.h, there are if defined this, or this, then run this code. So this is the way that the Menuconfig and the code kind of play together to enable or disable configurable portions of the drivers. Now that we've got this all up and going and flashing, we should be able to see through our serial port that it's running, but well, I'm not seeing it. I think I probably missed one other step, but I'll tack that on to the notes at the end of the talk so that you can get up and running with just a simple print K, print F too. Let's jump back to the slides since I've been going off slide deck a little bit, and walk through the kind of the remaining pieces of the talk. And yeah, so really the example I had planned on showing was about the bootloader, which is having to do with Menuconfig. As I mentioned, references are config_stars, and we use Menuconfig to get there. MCUboot is the new bootloader. Lest Flash is smart enough to still do the right thing and merge a hex together, because you actually get two different pieces when you use the bootloader. Let's check that out real quick. So we'll go to Menuconfig. We'll check out MCUboot. Add MCU bootloader support. Save our new configuration. Do a flash. All right, and now we've got our device. It's still blinking. A little hard to tell, but it is running the bootloader. I think the easiest way to tell that it's running the bootloader now is that we've got a much larger address space that's being programmed. And that bootloader, of course, allows all kinds of reprogrammability in the field, which are kind of requirements for any production class device. Let me just check. All right. So, let's see. Now going back to the slides. Yep, and again, in the slides, you can have a reference here really well to see how that goes. Yeah, so let's just take a few minutes then to kind of jump into Segger Studio. I'll mention, I think there's a bug right now at Segger Studio where it does not handle like bootloader files, right? Or bootloader enabled images or Zephyr projects right now. I'm going to show you what that looks like, because it actually looks very similar to when you have a Zephyr file that's not correctly loading either, and it's kind of easy to do. So I've run into it a number of times, and it's not particularly intuitive what's happening. But here's what Segger Studio, a fairly recent version, and you notice I've got the Nordic edition, and I mentioned earlier how we make sure we get the Nordic edition. That's important. The regular Segger Studio edition that you download from Segger's site does not have this Open NRF Connect SDK project menu item. So and that's required to open up Zephyr projects. Zephyr uses a tool called CMake as part of its build system, and Segger Studio out of the box does not have support for CMake-based projects, and that's part of what the Nordic edition adds, and it's required for Zephyr projects. So when you do that to open it, you point it at your a couple of things. You're pointing it at your CMake list.txt file, which in our case is inside of samples basic Blinky. And then you also point it at your board directory, which previously when we did west from the command line, we specified just the board name, but here you need to provide the full path. If multiple boards are supported by that particular path, you'd have a drop down here. Here we've only got one option. And then you tell it where you want your build to be. And this is just almost always should be just a directory called build inside of your NCS directory. If for the first time, if you want to, you can clean the build directory. As I mentioned, in this case, I plan on it erroring out, and I'll show you what the error is and how it's not terribly helpful. But that's because we have a bootloader enabled, and we'll disable the bootloader. Yep. So this is what happens when it doesn't work well. You get the project file is invalid. Really, what it's saying is that something about your its importing of the CMake lists and information here is not correct. But obviously, I think Nordic has a little bit of work to do to make this error a little more intuitive. But for now, this is kind of what you get. And that's just kind of your clue that, hey, something about this doesn't work. And in my experience, what this is the bootloader projects just aren't supported. And so if we jump back to here, go back to Menuconfig. Yeah, and I think we need to delete our build directory so that we can get back to a good state. So let's build again for our nRF52 PCA 10056. We're going to build the Zephyr samples Blinky. Basic Blinky. Blinky, there we go. This will reset all of those customizations that we had as far from the Menuconfig. So if we go back into Menuconfig, we'll see that MCUboot should now be disabled. Yeah, and we've got a no there. So this should import into Segger Studio pretty easily. So we'll try this one more time. Here we're pointing at the same place, basic Blinky, this. Hit OK. Oh, look, we still have a solution is invalid. Huh. Cool. Well, we might need to debug exactly what's going on. Oh, no module named West. So what's happening here is West has updated its requirements here. So we have a updated version of Python, but West is not in my in Python 3 globally. So that's I guess another thing is like the virtual environment stuff that I was doing in order to install West locally is not enough for Segger to run here. So what we need to do is get out of my virtual environment by deactivating and then running pip to install West globally. That's what I don't necessarily like to do. But if you want to use Segger and use its stuff, then that's what you got to do. I think that was Python 3, right? It must be. So now if I run West, let's see, what do we get? So now this is a version of West that's running globally. And yeah, it's running under Python 3.7. So, and this is my global Python installation. So now, if we, with any luck, if we try this again, Yep, so now we were able to pull it in. You'll notice that it's a little messy, to be honest, too. I think like this is still super nice for debugging. I think this is the best debugging experience you can get right now. But the CMake integration is still a little rough, I'd say. You can find your code. It's buried under project libapp ccompiler app, but here is our main.c. You can set breakpoints. You can build your ELF file. And then you can debug it. And if you've got a board connected like we do, you can debug and you can see we get, we have single step debugging. We can jump out of things. We can, basically, and the device is blinking now again. So you have a couple of different ways to debug. You know, it's like, as I'm mentioning, it's a little rough still, but it works. I also have really good luck in Visual Studio Code. They do have something called the Cortex-M debug plugin, and that does actually provide some pretty decent debugging support as well. If you have questions about how to set that up, feel free to hit me up and offline, and I'd be happy to share that. With that, that's kind of just getting started with Zephyr. As you can see, there's a lot of details, devil in the details, and there's also a lot of power behind this project. There's a lot of momentum behind it, so I think we'll just see it continue to improve as we go, and it's really kind of an exciting platform moving in the future. If there's any questions, feel free to toss them in the chat or unmute too if you like, and I'm happy to take them verbally as well. All right. Well, if there aren't any questions, thank you so much for joining me. Really appreciate your time. And, you know, as mentioned, open invitation, check out dojo5.com and feel free to email either at hello@dojo5 or find me directly on LinkedIn. I'm very happy to entertain any questions, discussions about embedded topics of any kind. So thanks so much for your time. Appreciate it. Have a great day, everyone.